All right, here we go. So week two of our podcast. Got a name, Token Drop, right?
Yep.
So last week I started off by saying we're going to keep it to 15, 20 minutes, no more than half an hour. And what did I do? We kind of just blew past that. It's an interesting conversation, but it was beyond the time we had set. So this week we'll try and keep it to no more than 30 minutes, hopefully less than that. And so, last week we talked about hallucinations. And one of the things that people have said about hallucinations is that people hallucinate. Hallucinations are mistakes, right? Employees hallucinate or make mistakes, and people are okay with that. So why shouldn't be people be okay with hallucinations or mistakes in the LLM? And I got thinking about that, and I, like you, Sam, started off in the semiconductor world. And one of the things that we used to do, we had all these different protocols, including familiar protocols like USB. And there, we didn't tolerate hallucinations or mistakes. They had error correction mechanisms put into place. For ECC for memory forward error correction, for SerDes, 8-bit, 10-bit for things like I think USB uses it, etc. So people did not accept it in machines, and people don't accept mistakes made by employees uh, either. You give them feedback, you give them training, you ask them to do self-reflection, et cetera, et cetera. So I think the premise of, hey, it's okay humans making it, it's okay that machines make it is not valid. And what I want to do today is there's been certainly a lot of things like we talked about right now about how you correct mistakes in semiconductors in protocols. What are some of the techniques that can be used to correct or let's say mitigate hallucinations in LLMs? So let's use that as the discussion point for this week. And what do you think, Sajan?
So one thing, right? I'm really thinking this loud, right? I really think you brought a very brilliant point, actually. Um, uh, you know,
It wasn't my
I
point. You brought it up, but when we talked
Well,
offline.
well, it was mutual, right? Because
Yeah.
one of the questions that came up was, okay, so there is bare encoding, and it is used for error correction, like we have 8B, BABA, 10B encoding scheme and stuff like that. Now, the main premise there is errors are inevitable, right?
That's
Now,
right.
suppose if we treat hallucinations to be inevitable, right? And it's something we have to live with, actually. The question then becomes, do we have something equivalent to that? Can we correct these hallucinations? So that is the main point, right? That's where you're
Mhm.
going into it,
What's the
right?
answer?
Well, it's pretty complex. I don't think we have an answer for that, and it's because of the very
But
nature
is
of
it
what
is it in chunks? I
hallucinations
mean, we
is,
can't
right?
maybe have
Uh,
do we have like bite-sized pieces that we can take a bite at this hallucination problem and solve it?
I
Is that
really
what you're
think
saying?
there are some places where there is an analogy, but then the analogy breaks down very badly at certain places, actually. And that is exactly the point I was trying to make. So, for example, when you talk about errors are random or stochastic in nature, right? They appear randomly. You cannot say errors are predictable. But when you look at hallucinations, they are structured and systematic in nature, right? That's one thing I really see. Secondly, the error distribution is known or is characterizable. Like you can put it down into a spectrum and be able to really quantify that, right? Hallucination distribution is unknown, and it's context dependent at that level, right? So that is one of the things that I really think is very important. And also, correct signal exists independently, right? Here, the ground truth may not exist or even be
Hmm.
undefined in the case of
That's right.
hallucination, right? So there are many things which you can see, like errors don't know what you want, and hallucinations are fluent. They look like correct answers, actually. Same thing, like when you look at decoder knows where errors likely are in the case of bare encoding and stuff like that. But you can't really tell it, look at something and localize where the hallucination occurred,
But
actually. So there are
but
many points where
but haven't we done that like we did that oil and gas case study, right? The customer, right, Sajat? We did that oil and gas case study where the customer asked us to look at that Santos document. And there is a ground truth because there's this oil well drilling report where they gave us a couple of questions to ask, and we were able to show how our technology was able to, answer the question correctly versus incorrectly via just an LLM only. So there was a ground truth that we could compare against. And
No, even in that case, I agree with you when you say well, I'll let Sujad answer that. He's talking about ground truth, Sujad, actually. Can you? I mean, do you have any points on that? Because just wanted to, right.
Yeah. When you speak of machines, the human expectation is that they perform as designed,
Mhm.
which means, and that's why we have human language that says it works like clockwork, which means it's supposed to be working as designed, which means we have a higher standard for machines and we're not tolerant of errors in machines. We expect them to work all the time according to spec. In the physical world, yes, there could be errors. Um, it's a function of the physics of or the mechanics
yeah, the ones and zeros at the bit level, right?
of the systems, right?
Yeah.
Um, you spoke about network errors, you spoke about all kinds of errors, machine errors in semiconductor technology. Yes, and you do have errors, and that's because of the physical reality, which
Hmm.
means
Hmm.
um, you have cosmic rays, you have crystals made from quartz, and there's a good likelihood that given two different clocks, that are expected to operate at 50 megahertz every time, all the time. But if they're made from two different crystals, from extracted from two different mountains, and those crystals can have defects, you could still have variation because there's a physical element there, because of which you could have errors. But software is different. You abstract it at a logical level.
That's right.
It's like mathematics, it's logic. 2 plus 2 should always be 4.
That's right.
I mean, there's no question of errors creeping in there.
Yeah.
So that's what we're used to. One, we expect much more of machines, even in the physical world. And the expectation is even higher when you abstract them and build software systems. So, which is why these hallucinations by LLMs are, they come as a surprise and they come as a shock, and you want to be able to deal with that.
So what can you do then? Going back to my question, what can you do to in an abstracted system like this, right? It's knowledge, not bits. How can you mitigate?
Yes.
Okay.
So oftentimes, when in the context of LLMs, we're building systems that don't necessarily depend on the parametric knowledge of the LLM. We augment that with knowledge that's manifested in documents. So if you're um, inquiring about, if you got a question inquiring about some fact, so oftentimes in classical LLM architectures, you got actually have um, you augment the internal metrics, internal knowledge of a LLM with a document, right? Because the LLM's knowledge has a cutoff. It was trained at a particular point in time. So you expect its knowledge to be dated at least to that extent. Number two, it's got this lossy, compressive semantic knowledge storage, which means on the way in, there's lossy compression happening with the knowledge. And on the way out, as you're extracting, you're making probabilistic, inferences, which means once again, you're predicting tokens. There's a potential for error. So there's potential for errors with the knowledge going in to an LLM, but there's a potential for errors with the knowledge coming out. And in order to avoid the dating effect, classical enterprise architectures, they use what are known as RAG systems. You augment an LLM with documents. Documents with defined, definite facts. And you expect the LLM to be able to answer questions against the knowledge stored in those documents. And then you'd believe that you've mitigated the risk of the knowledge going into the machine, and therefore you reduce the hallucination risk. And the answer is yes, you've reduced the risk, but that risk hasn't gone down to zero.
Yeah, you
Even
can mitigate it. You can't get rid of it.
even in a RAG architecture, LLMs do hallucinate, even with the RAG architecture. So yeah, RAG is one way to minimize and mitigate that risk, but that alone is not the answer. You still have to have verification mechanisms. So post the synthesis, you still have to have some kind of verification mechanism to making sure that the answer that the LLM gave you got to verify that against the ground truth, which is the document that served as a source of knowledge for the LLM. So you have to verify, and oftentimes those verification architectures end up being pretty sophisticated. That you can do fact claim by claim verification, you can do embeddings to do comparisons. Um, and there's a whole science behind the verification that you perform. So it's a function of the sophistication of the verification that you put in place and the amount of time and money you have that you can spend on it, right? So that's and
You say
oftentimes
the
it's
more verification you do, the more it's going to cost, more tokens, and the
yes,
more time. So if
yes.
you want to have the most truthful answer, you do more verifications.
And in this RAG architectures, it's not that your answer might be in one document, your answer might be spread
Sure.
across multiple documents. So you end up providing multiple documents. Then how do you rank those documents? How do you do pre-synthesis verification? So I spoke about post-synthesis verification earlier, but we can also do pre-synthesis verification just to make sure you have the right set of facts that you're feeding the LLM to then generate the answer. So
So
there is,
what do you mean by do you mean like a prompt engineering, or it's something different?
yes, you want to, of all the documents that you collected that might potentially have the answer, you want to, once again, as Sam said, right? It's a context window. So you want to make sure that the highest priority documents that have the highest likelihood of serving the answer are ranked higher up in the order, and those that likely are less likely to have the answers are ranked lower in the priority order, and then you feed these documents. So that's another way. It's called re-ranking. So you do re-ranking of these documents. You can also do pre-synthesis verification just to make sure the answer is actually indeed contained within those documents. So you could also do that. So yeah, there are various ways of running verification, but it really is a function of how critical is, how truthful you want your answer to be
Yeah.
and
See,
how much are you willing to invest in it.
I think one thing, right? Sajad brought a very important point, right? I mean, for example, today you take all these LLM and RAG systems, right? You're talking about grounding layers, right? RAG, two calls, structured knowledge, etc. But look at what the real problem there is. It has only one shot at giving everything to the LLM. So it takes all this, loops everything together, pushes everything to the LLM and says, here are the chunks, here are the related stuff, go figure it out, right? It has only one thing. But do you reason like that? You don't, right? I mean, basically, reasoning is a chain of thought. Like you first try to understand certain things, and once you understand, you ask better questions. The notion of human understanding is something different because we don't really go and collect everything together by some semantic chunks, group them together. That's not how we really reason about things, right? The way humans reason is we go one step at a time. You take a book and you start studying it. You now generally understand the outline. You understand the main theme in that. And then you start asking things further. Like, so in other words, there is this back and forth which happens, right, when you are even assimilating information. But in a typical naive system, there is only one shot. And so when you have that, it is going to be overwhelmed with that data which is presented. Actually, it could. I mean, I'm not saying it's always, but it could get overwhelmed with the data that's presented, actually. And think about it, right? The attention mechanism within the transformer. It's like relative to every other thing you have weights. Now, what happens if I give you a million words or more than that, and I give you an entire thing which can cross context windows? Some of these words which have importance are getting lost because it's diluted at that level, right? So now what is happening basically is because of that very nature, people are starting to really want to use reinforcement learning. Because in reinforcement learning, what happens is you just go back and you start asking questions, and then you go and then you get back and again ask another question. So in other words, that reasoning capability is what sets humans apart from other things actually. So how do you bring that reasoning into the overall notion of really understanding things,
You're saying
and then
add
start
reasoning in
bring
to
down
mitigate.
hallucination,
You're
right?
saying add reasoning to mitigate hallucinations. Is that what you're saying?
Exactly. I mean, that's something I think even Sajad and I were talking earlier, that this kind of reasoning capability is one of the main things that will distinguish things. Otherwise, what happens is you cannot take everything that's available. Like, what do? You go in you vectorize the whole thing, and then you look at the space, and then you pull all related chunks, whether they are when
Right.
they're
But when we had,
if
let me ask you, we used to have one of our products, when we were using an older generation LLM, we used to have this chain of thought reasoning that it used to spit out, the LLM used to spit out its thought process. And
right.
but
I mean, you
so
need to
isn't
go
it
back
doing it
and
all?
forth on that.
But isn't it doing that already? If we were doing it with an older LLM,
But again, did you do it with the rewards model is the question, right? I mean, when you reason, you need to also have a reward model associated with it, because when it does well, then you start rewarding it, right? Now,
mhm.
one of the things that the latest models do is they don't reward you for really providing the right answer, because sometimes the LLM can take shortcuts. It says, how did you arrive at this answer? Tell me every step, and I'm going to give you a reward for that, right? When you have that, you have explainable AI actually, because LLM needs to really explain every step that it took to arrive at the answer. It's not the answer that's more relevant, it's the process that's very important. When you start really making your rewards in tune with that, then the reasoning takes a
Right.
different
But that's an
behavior
LLM
actually.
thing, right? So that's nothing we can affect as just a user of an LLM. We can't affect that. That Anthropic and OpenAI, et cetera, they got to
No,
do that.
today they are having agents which are being built. The agentic portion is one part, and the LLM is the other portion. So these agents can really look at this data and start really doing this chain of thought reasoning actually
Right.
with the
But I think
LLM.
that's outside of the LLM, right? That's everything that's built around. It's a system. It's a solution built around the LLM, isn't it?
That's right. But they're two components of the same thing because they don't treat it as a separate system.
Yeah,
Um,
I
they
understand.
they need to train these agents anyways, actually, right?
Yeah.
I mean, they need to train the agents, and those agents really are looking at this particular thing, and then it goes through the slow process of reasoning, and it moves forward actually, and that is the latest trend right now. Now the question is, there is a friction going on between these two different things actually. Do I develop the actual agentic part of it, or do I really build more complex models? Like for example, in your traditional day-to-day thing, you have only binary relationships, right? They are very they don't depict the whole world, right? I mean, the whole world is interconnected. It is interconnected to that extent that breaking them down into binary relationships, right? If you really break them down, then completely you lose information, right? I
Right.
mean, and again, we're exploring a different area. Why I brought that was because there is a tension going on today in the industry where people are trying to either build this agentic stuff which can do the reasoning, or they want to enhance the model from just not supporting binary relation. They want to go n-ary actually, right? They even talked about something called the hyperedge. The hyperedge is like something which connects different entities together, right? I mean, again, we don't need to go into the details of that, but what I'm trying to say is that reasoning with rewards needs to be there. And then we need to the LLM needs to be able to explain every step it took, right? I mean, on how something was arrived. I mean, and the agentic system, along with not the binary relation, but n-ary relations,
Mhm.
it start to make a big difference, actually, right? I mean, in
So
how,
we're
and
about
again,
20,
this is
we're
there.
about 20 minutes in. I'd like to maybe 5 or 10 minutes more. You guys want to discuss this some more, or something else we want to discuss?
No, I think I want to just say that we tend to anthropomorphize LLMs by according them human abilities, reasoning being one of them, right? So, you know, and these models have been, to a degree, you see now, I think a lot of models are branded and labeled and marketed as reasoning models, right? And that's because it's the quality of the training and how they train with reasoning data sets. There's post-training alignment. Effectively, there's a RLHF, like it's like a rewards model. So there's human feedback that's used to better train and align these models. And all of these techniques have yielded good results, but the fundamental fact remains that this are next token prediction machines that are trying to recall the answer from memory. And there's been a lot of content published, a lot of papers published on, you know, on the reasoning abilities, on the problem solving abilities, on the math abilities. Apple just recently published a paper on the math abilities. And everyone is beginning to converge on the same answer, which is they're recalling these patterns from memory. So they're really, really good at storing a lot of these patterns in memory and being able to recall them with the fluency and speed that you tend to anthropomorphize these machines, that these machines are thinking, these machines are reasoning, these machines are strategizing, they're planning. The answer is no, or I think, they're recalling from memory. But they're really good at that. So I don't want to underplay, their abilities. Their abilities here can certainly significantly help uh, increase velocity in the things that you can do. All I argue for is make sure there are enough guardrails, right?
Mhm.
Some verification
Yeah,
tests at the right,
the system.
yeah. So you design a system. So that's why I think it's an architectural issue. So you
Yeah.
really need to address this from an architecture perspective until hopefully someday a better model comes along. And I recall Andre Karpathy, it's not even so much his thinking was, it's not so much the volume of data with which you train these systems. It's the chains of thoughts, the trajectories of human thinking that leads you to problem solving. If those trajectories of thought, if those human, chains of thinking that led to a problem being solved, if they can be captured and used to train these models in every sphere of human activity, whether it's in maths, whether it's in science or entertainment and such. So his argument is that you might need lesser training data and you can train these models far more efficiently. but it's too often the case you don't register such things, right? I mean, at the end of the day, it's a written word. So you just declare that you solved a particular problem in the real world, in the physical world. You don't describe exactly how you solved the problem. You say, hey, your car had a flat tire and you went and fixed it. Yeah, you don't take a step-by-step approach to describing exactly how you fixed it. So, so that level of those kinds of trajectories of thinking are far rarer in the training corpus that these models are trained with. And his thinking, Andre's thinking, was that if we had sufficient quantities of those, you don't need as much training data.
You still need a system, but right? I don't think
Yes,
it's
yes,
right.
you still need.
See,
Yeah,
this,
but
this
all of this is assuming that you're working with the current architectures.
Hmm.
Look at the work that's going on right now with Jan LeCun. He's reached a conclusion that you need a new architecture. He's working on something called JEPA. He's working on something
yeah.
called world models, and I think there's a lot of work there that's going on. We don't know when we can expect to see that work see the light of day. So it's going to be sometimes away. So until then, what we can do in the meanwhile to apply this to business applications is to build this verification mechanisms. And the smarter you are in verifying your answers and correcting your answers,
Hmm.
and
It's
the
not just post verification, is what you said, right? If I understood correctly, pre-synthesis, you said as well.
yes, there's pre-synthesis, there's post-synthesis,
Because I'm
uh,
familiar with post, but I wasn't
Yeah.
aware of pre.
and you might end up either surgically rewriting part of your answer or
Hmm.
rewriting all
See,
of
for
the
example,
answer.
right, Sunil, I wanted to bring this point. I think you might appreciate this.
Yeah, 2 minutes, Sam. I'd like to
In
finish up.
olden days, we used to do something called link discovery, right?
Hmm.
Discovering links, who is
Yeah,
connected to who. Okay. That was a very tough problem, you know. You know
internet
why? Because
protocol,
we
isn't
never
it? What
had
they?
LLDP, CDP, or any kind of mechanism to do neighbor discovery. We didn't define anything, right?
Yeah.
So we used to go at the bottommost layer called the AFT, right? AFT analysis is one of the toughest because you have the CAFT, AFT intersections, and you need to see who saw who and which MAC appeared in which way. You had to be highly mathematical to calculate all those things. And it used to take a very, very long time, right? I wrote one of the earliest link discovery modules actually. And I certainly had to define live on AFT analysis at the bottommost layer, then a little bit of STP, spanning tree protocol, and then because it gave some directionality. Then came further algorithms like LLDP, CDP, EDP protocols, etc. Right? Now, why was all this done? To really determine the confidence level, right? Now, suppose you're able to use all these multiple sources and able to say for sure, yes, there is a link, then the probability of having a link is better, right?
Hmm.
So Sajad brought a very interesting thing called confidence calibration, right? So we talk about grounding layer, we talk about self-sufficiency or chain of thought, consistency or chain of thought. Now I'm bringing the notion of confidence calibration, models that express uncertainty rather than bluffing, right? This is still an open research problem, but when can it say with confidence, yes, I am certain about this answer, actually, right?
Or
That is
70% confident or whatever.
right. That is
Yeah.
the problem, right? I mean, at least in other cases, we can have confidence levels with multiple sources. Can we do that here? That's the one
Mhm.
question I have, open question, right? The second thing
Yes.
is all this is domain scoped because we had the discussion in the morning, actually. Remember, and we talked about it, and they are domain scoped because the task space is of this is very much confined. And that's why I said the
Domain, you
ground
mean like
can
oil
be
and
there
gas
or
or
not.
finance or something like that, right? Or
Exactly.
semiconductor.
Exactly. And if you're in this domain, say for example, you have an ontology in a particular area that applies to that, and everything else appears foreign to you, actually, right? So that's why I said the ground truth either is there or not. I didn't say, I didn't base it on ontology alone because that is only in that domain space. So therefore, it is domain scoped also in a sense. So therefore, you have all these five things. which are going to be there, which is both the grounding layer, the self-consistency, and the critic models, right? The second pass that challenge the output, confidence
Right.
calibration, and domain scope development. Those five are integral to that overall thing that I think
Yeah.
Sia was alluding
Hey,
to, I
Sam,
think.
I'd like to kind of wrap it up. I said half an hour, so we're
Yeah,
up on half an hour.
yeah.
So I think we can discuss some of these things next time or one of the future podcasts.
Yeah, so yeah,
And,
just do you have any concluding because we talked about this, so we talked
yeah,
about. Can you give a couple of words on the confidence calibration aspect and the domain scope?
maybe we can discuss it next time because I'd really like
Okay,
to keep it to half an hour.
there you go. Yeah,
Yeah, I said I would. I don't want to break my promise 2 weeks in a row.
yeah.
So,
Cool.
okay,
All right.
anything else, guys?
No,
Otherwise,
thank you.
we'll talk to you later.
Cool.
Yeah.
Thanks, man. Thank
Thank
you.
you.
Bye.